Great. So if I will ask you first regarding this video, what do you mean the main definition of network access control before we start to see my explanation in the slides? Okay, how to go next? Okay, what's access control means? Access control or controlling how to access the network, as Paul mentioned in the video, it's really a computer network solution. This solution should define a set of policies, a set of metrics, a set of resources, and how these resources should be accessed by some subjects or some users. So the network access control is a computer network solution. This solution allow the users who want to access any organization or home network to have, let's say, a set of policies before start their transfer via our network, right? So as we see in this slide, let's say access control has three main pillars: the users, or it's the subjects, and sometimes these users are known as processors or processes. So let's say we have a set of processes and set of users, and these users want to access a set of system resources, and one of these resources is the computer networks. That's why access control in general, it might be accessing any other resources. So we have a set of users and a set of resources, and then we have the security policy, which means how these users should interact with these resources. And we will see in a bit an access control matrix where you can define user X can read or write or delete some file from a resource or from a system resource. So this is mainly the general idea or the general definition of access control. And to be honest, network access control, it's, let's say, controlling the access at the edge of the network. So it's the first thing of the network. It allows everybody who want to connect with our network to follow the network policy. And let's say if you have a Wi-Fi network at your home, and if somebody stop at your door and connect on your Wi-Fi, so you need a policy to let that person connect on the network, or prevent or prohibit that person from connecting on your network. And sometimes this kind of policy is not really written. It's a technique. For example, at your home, you are using an encryption wireless network. So if that guest or that user at your door does not have your encryption key, that means he does not connect at your network. And some kind also of network access control is to perform a health check. Health check means, is that device want to connect at, let's say, our university, is a trusted device? Is that device has an antivirus on it? Is the antivirus, for example, updated? Or is the antivirus software is the recommended one, or recommended by the university, for example? Is this device belongs to an employee or a student at the university or something like this? Is it a mobile device or a laptop, or does it use Windows, and is the Windows updated, or the Mac OS, and so on? So all of these healthy check is defined as an access control. So there are many examples on access controls, right? So access control, for example, the pen on ATM cash machine or ATM cards is an access control. The password is an access control. The access control list, which define at the firewall, of course, which define who can access what, is an access control. To lock your door or to lock A file cabinet is an access control, so you need a card or a key to access that file cabinet. That's an access control. A guest list who can enter for a dinner party or something is an access control as well. Right. So this is mainly the definition of network access control. But I want to ask in general, why do you think network access control has appeared in network security? True, to protect our network from any malicious, let's say, unauthorized user. Yes, and your network, that's true. So to protect any kind of network, to protect who can access what, as network access control is needed. So imagine that you are in a journey and you are at some hotels and you want to access the hotel Wi-Fi. So if the network does not recognize who are you and what are you doing, so they will not allow you to access the network. And I was looking for robot answer because access control may be increased and the need of access control solution increased after getting wireless network and after getting wireless devices and mobile devices as well. So you can't know who is the user of this device because of the many devices that are requesting to access the network. To be honest, we will talk about VLAN maybe in the NAB, but I will just draw a symbol. Do you know that the network switch has many ports on it? And one of the main network access control is called IEEE 802.1x, 802.1x. And that technique is which is NAC, port-based network access control, which define that, for example, if we have these 4 ports, 2 of them belongs, let's say, to the VLAN 1, which is the accounting department, for example. So if any PCs are linked to this port, can access all the other devices linked to the same VLAN, while they can't access the other VLANs on the switch. So during this VLANs, only the allowed devices can access the accounting VLAN. And we have many kind of VLANs. We have let's say VLANs in the same geographical place, which is as the 802.1x, the port-based network access control. And we have also the virtual private area network, or the VPNs as well, which are to connect 2 different locations through tunneling process or through the internet with 2 different geographical locations, and to let these devices access as they are in the same LAN. But we need to explain them together. So the first one is mitigation of zero-day attack. And it's clear that if we have a network access control, then we are preventing any unauthorized PCs or any unauthorized user from getting their access to our network, and that will really reduce the number of attacks and mitigate any zero-day attacks. Also, the second goal is to give authorization, authentication, and accounting. And in a bit, in the second slide and third slide, we will see what's the main definition of authentication, authorization, and why not do it now before continuing the goal. So what's the difference between authentication, authorization, authentication, and accounting? So authentication mainly is to let the network know who is accessing this network. So if X want to access this network, So the network should make sure that the entity who want to access this network is the one who claimed. So if Hesham want to access this network, so the network should provide some mechanism to let Hesham prove that he is Hesham, or by using a password, a PIN, a fingerprint, whatever accessible in the network. And this kind of authentication, it's called a service that the network should provide, and the network should provide a mechanism to identify the identity of any entity who want to access the network. So, for example, most of us, when we are using the university wireless, we should provide our ID and password, and that is an authentication technique. And we have to have an authorization. Authorization means something different. Authorization means the privilege that you have. So some user, they might have, for example, on the e-learning system, some user, they have only to read from that e-learning system. And let's say instructors and staff, they can modify marks, grades, upload material, presentation, etc. So authorization means to determine the privilege of the user on the system, and that's what determining what the subject can do. So, and the last one, which is accountability, and mainly accountability is to measure all the traffic. And that's really, it's like a log file that you have to record every single access and every single request and response in the network. And this accountability, it might be used also for billing system, especially in the cloud infrastructure. And also it can be used, as I guess Rowan mentioned, for crime detection and so on. When we go back to all the history and log file, who accessed our network and when, and what they have done and so on. So this is the 3 A's of access control, which is called authentication, authorization, accountability. The third goal of network access control is to encryption of traffic, especially to the wireless network. And also it can be used also in the wired network. And in the wired network, we usually use the 802.1x, which is the port-based network access control, as we explained before. Also, we can use the network access control to define the role-based, which means each user and the role of that user on every device, on every process, on every application in the network. And that is a role-based control. And we normally use that role-based control to detect any intrusion in the network. So we can use network access control to support the intrusion detection system, and also to identify the malicious, let's say, or that users who can be intruder. And sometimes having more than one security solution in the network, they support each other. Also, the other goal of having a NAC or network access control solution is the automation process of define the network role. And this means that we can have an automated process to define any jailbreak or any threats or any vulnerability inside the network. Having network access control also means that we have one policy, and that policy should be followed by everybody. And this is called policy enforcement. Enforcement means that you define a policy that everybody, every computer, every user accessed your network should allow their PCs or their laptops or their devices to follow that policy from the moment they accept to be connected to your switches or to your router or to your network middle boxes. So that means a policy enforcement. And also, the other goal of having network access control is to identity and access management, which means that sometimes you are giving an IP address to a user who are not recognized for you. That's why having network access control will let you know who's accessing this IP addressing, or who's accessing your network by this IP address, or who is the authenticated user identity inside your network, which is very important for all kind of network. Okay, guys, so this is mainly an access control matrix, which we described before. The columns, the columns which are the columns which are the object, and the rows are the subject. So the object means any process, any resource, you have it inside your network. So, for example, you have for this access control. It's not really for a network. It's for operating system. So, for example, who can access the file in the trash? Who can access the file a.out? Who can access all text files? And we have two subjects, or two users, or two entities, Jason and Mike, and we are defining a set of entries. This set define the access operation. For example, we have read and write and X, which means delete. So this kind of access control matrix might be used on the firewall, called user permission. It is, yes, it is your user permission. You can define this user permission per file, or you can define it per system. So if you define it per file, it's a user privilege, but or permission. If you define it per system, access control matrix, or sometimes they call it access control list. Yes, X is execute, true, and R is read, and W is write. And you can define any other kind of operation as well. All right. Two implementation approach for access control list and capabilities. But before talking about access control list and capabilities, Paul has mentioned in his video that we have two concepts for defining network access control: the pre-admission and the post-admission. What do you think the main difference by the pre-admission and the post-admission? It's a two prevailing design in NAC. Yeah, but I want to just add on that. For example, if we have a client who wants to access our network, and that client, for example, has out-of-date antivirus, or has an unupdated operating system, so we prevent that client from accessing our network until they have everything updated. While the post, this is called pre-admission. While the post-admission mainly is to follow up on all the user after getting their access to our network, and then based on their let's say actions on the network, we can have a further decision on enforcing them to disconnect, or enforcing them to follow some policies that we are defining in the network, and that policy should be followed. So basically, as Kai said, pre-admission is to control who can access before their access to the network, while post-admission is to follow up with the user after accessing the network and see what they are doing in the network and what action they have done. That's right. And also Paul mentioned, because these stuff are not mentioned in the slide here, that's why I want to focus on them. Also Paul mentioned that we have two fundamental ideas behind network access control: the agent and the agentless network access control. I want somebody else rather than Kais to let me know what do you think the difference between the agent and the agentless network access control? Sure. So agent network access control, they are using an agent software and they require an agent software. So for example, you have an agent for Google Drive here, right? So if you don't have an agent for Google Drive, you can't access the Google Drive itself. And other kind of network, they provide you with the agent software that you have to download. And some hotels as well, they provide you with their application that you have to download in order to connect to their Wi-Fi. And this is called agent software network access control. While the other kind of network access control, which are called agentless, they do not provide you with any required software to be downloaded on your machine, but they use scanning systems and scanning solution to find any network inventory techniques and to detect any discern characteristics remotely by the network itself. So this is mainly the difference between agent and agentless access control. One of the famous agent network access agent is called network access protection, and this network access protection is an agent to the Windows server, and it's included in many versions of Windows 7, Vista, XP, and other Linux as well versions. All right. Okay, so let's follow up on two definitions: access control and capability list. We will come in a bit about the difference between access control and capability, but mainly access control is to know what resources is accessed by who and what's the operation that can be performed on that object. While the capability list is focused on the who can use these resources or not, right? Okay, so as we mentioned, the main, let's say, access control is provided by the firewall, and we have many kinds of firewall. And as you see here, a firewall is something between your local area network and the WAN or the wide area network, or the wireless, not the wireless, the wide area network. And mainly, if we can define a firewall like a bottleneck who check all the packets come to your network and who check all the packets going out from your network. We have many different type of firewall. The first of which is stateless packet filter. Stateless packet filter, which define the rules of the packets who can pass through this firewall based on the IP addresses and the protocol is used and the port number, without looking into the packet content itself and without controlling the data inside these packets. So the stateless packet filter, it's only giving access based on the source IP, the destination IP. For example, you can see in the table below here that we have a certain source. They can't talk with a certain destination because the action is denied. And the destination 123 dot star, for example, if we can imagine this is an IP address, it's all allowed to be, let's say, contacted from our employee, for example. And in the third law, all the destination IP address 123.8 on a certain port or in the port not equal to 53 is denied. So this is only an example to let you know that the stateless packet filter, it's based on IP addresses, port numbers, right? And the other kind of firewall, which is the stateful filter, which is also based on IP address, port number, and also sequence number. But it's the difference between a stateful filter firewall and stateless filter firewall that we also examine the content of the packet. So we also look for the headers of the packet. We also establish the connection based on what's inside these packets, right? The third type of the firewall is called application level filter firewall, and sometimes they call it proxy firewall, because they examine the application used in the packet. So for example, this packet is a web server packet, a database packet, or a TCP packet or UDP packet based on the application layer protocol. And they, let's say, prevent any kind of malicious application to be accessed from outside or to be sent to our network. But all of these kind of firewall, to be honest, has some challenges. One of these challenges is consistency. Consistency means we need to place this firewall in a position that can see all the packets coming to our network or going out from our network. And also the other challenge, that these firewalls should be efficient enough to avoid any bandwidth traffic and to avoid any congestion that they could provide to our network, or they could make it inside the network. And these firewalls should be scalable enough to handle any kind of traffic, especially with a huge number of devices inside a local area network. Also these firewall, they should be placed either on the end host, which means that just before the host, and they can examine all the packet coming to a certain host, or it can be in front of the host, which means that it can be before the local area network, or it can be attached to the gateway to the internet, which means it's like the network access control at the edge of the network, and that means before going to the outside world, before going to the internet, or it could be a software implemented on the router itself. Right. So this is mainly a brief about firewall, and we have also the other kind of access control. The first one was the matrix, the access control list, or the access control matrix. The second kind is the dynamic access control, and dynamic access control is mainly based on defining a policy, and it's called bring your device policy, and or PY. I will write it down here. PY, bring your own device policy. BYOD, right? And this kind of policy is really very dynamic, and an example of that is Ethan architecture, and also we will see in a bit the dynamic algorithm to, or the dynamic protocol to detect any access. So for example, if we have a domain controller, and that domain controller are issuing the IP addresses for all the hosts which are connected in our local area network. So for example, host A wanna access the domain controller in order to get an IP address, and in this example, if host A is Nick, for example, and host B is Martin, and Nick wanna access Martin and send ICQ messages. Let's say how host A or host B can get the IP addresses from the domain controller. So host A, they define that they have a secure binding state to the domain controller, and they ask the domain controller, hi, I'm host A, and they should provide an authentication technique, either a PIN number or a password, and then the domain controller, and they request an IP address for sure, and then the remote control will define the IP address for host A, and they let host A to be connected on a switch 3 and port 4. And that's all accounted and saved in the log file in the domain controller. So we know now that host A is connected on switch 3, port 4, and using this certain IP address. And NAC, they have to do the same thing. So NAC is also sending a hi message to the domain controller asking to provide an IP, and the domain controller, after checking the password of NAC and getting B authenticated, they have to provide with an IP address. And now we know that host B is linked on switch number 1 and port number 2. And afterward, they can use the network to send their messages between each of them. So this is Ethan architecture, and the other one is the dynamic access control, which basically means, excuse me, let me just focus on this and I will come back in a bit. So the dynamic access control means that we have 4 phases in each device want to access the network. So the first phase is the registration phase, and after, let's say, requesting the registration phase, each entity should provide an authentication way. So the second phase is authentication, and then if this client is authenticated, they can do the operation that they are allowed to do. But if these clients are not authenticated, then they will go to a certain zone in the network. It's called a quarantine network, and I'm sure that everybody now know what's a quarantine, especially after the many quarantine that we have here in Jordan. Okay, the network is the wrong place. Right, so sometimes even, and that's what Rowan just mentioned, even if you have the right access, even if you have the right validation or the right authentication information, sometimes you are enforced to go to the wrong network or not the appropriate network that you should use, and that's because of sometimes network access bandwidth or let's say poor visibility into some type of application, or because of the congestion at the firewall or VPNs, or even limited sphere of influence based on the remote user and exceptions. We have another type of access control. So we have 2 types now, the access control matrix and the dynamic access control. And we have also the cloud access control. And we use that kind of cloud access control with all the virtual machines. So when Khalid asks you to download the Oracle VirtualBox and to also install the Kali image on that, so you have a cloud access control installed with the Oracle VirtualBox. And as we mentioned before, if you don't have the agent for Dropbox or iCloud or Google Drive, then you can't access your cloud data. That's why cloud access control is really important to also the accountability, to also give you some billing information. So they might charge you if you have increased the certain amount of usage, or the certain bandwidth, or the certain capacity of storage, and so on. We have also Microsoft Active Directory, which also considered as an active control authentication server. The Active Directory basically know all the users linked inside the network, and it's also provide something called single sign-on, or SSO, which provide you with a single username and password to access all your Microsoft application and or your network resources. Another, let's say, alternative rather than network access control that we mentioned is the capability. So capability means that we have to identify the legitimate traffic. We also have to identify, let's say, the operation that each subjects can do, or focus on the users. Those users can, let's say, do some kinds of actions, while other users, they can do these kinds of actions. So it's like having them in groups and give capability to each group. So that's all I have for today, guys. See you. Bye-bye.